And maybe that's the end of the list. And so part of what you have to do is this, that if the command is delete Dan, then what should happen is this pointer here, so, is going to be changed. Right now, the value here points to Dan, but we need this value to point to George, so that this Dan and this Dan aren't in the list anymore. So one thing is we need to adjust pointers, and the purpose of adjusting the pointers is to leave out, if the command is delete Dan, the adjustment of the pointers is to leave Dan out of the list. So by changing, so Albert is right before Dan, so its next field here needs to be changed. That's part of it. And the second thing that you have to do is that these boxes with Dan in them have to be returned to the operating system. So the boxes containing Dan need be returned. So this is what we did. This is what we did on yesterday, right? We did this yesterday. What other operations could a person add?
To see if a name exists in the
We can see if a name exists in the list. That would be good. And what it would either return. How do you? Okay, I like that. Search.
modify.
So this would be like an S, right? So here's S and followed, and then we'd have a name. So S and some name like S and search for Dan. And what's that going to return?
How many Dans are in there?
It could return the number of Dans, or it could return the address of where the Dan is, except we don't really have any way of using that here. So maybe, so have this, it returns the number, so if it returns 0, then there are no Dans, right? So this returns the number, well, it's returning the number of Dans because we said search for Dan here. Okay, I like that. What else? Something that would be easy to do and make this wonderful program even more useful. Even more useful than it is.
We can modify print to make it print list is empty if there are no names in it.
Sure, you've done that already.
Oh.
Yeah, but that would be good. Right now, if the list is empty and you do this P operation, this is the print, I think it prints nothing. So it'd be nice to have it print, it should print out the words empty list. So we're accumulating things. One is this search operation, S, search. So example would be search Dan, and it returns the number of Dans. Okay, I'm accumulating things here. That's one. Second, the print operation, we already have a print operation which prints everything that's in the list. But if the list is empty, if list empty, it should print these words. List should print then list empty. Okay, what else? How about a quit operation? That if they type in Q, this is search example, and the example here was search Dan. P, if the list is empty, it should print empty list. Q, this is quit. It'd be nice to have one more. For what, rename or
Something
remove?
like that, remove, I was thinking rename,
But-
because we already have a remove.
Yeah, we already have, oh, yeah, we've already got this. So here's what we don't have the search. This is what we've got. Insert George, or whatever the name, print the list, delete whatever the name is. In this case, I've got Dan. And so we're thinking of adding a search, and we have the print, but we do not have this, that if the list is empty, we should print out list empty. Quit, that if they type a quit, the thing stops. Right now, I think you have to type like a Control-C. So we could just go ahead and do that, but I have a feeling that if I do it, then I'll have done it. Okay, so that's what happened with the delete, right? I kind of did the delete. So yeah, search, and what this does is returns the number of, if it's SDAN, it returns the so when it'll print on the screen the number of Dans in the list. The number of Dans in the list. This look okay or horribly impossible? What would be a strategy for doing the search? Say you're searching for Dan or you're searching for George. So it's S Dan or S George. Or why should we be
I feel
prejudiced?
like you use the same while condition as the delete.
Yeah, you're going to go through looking for what? You're going to go through looking for something that's going to match. Where is Dan going to be? This will be in this variable INPT. We're looking for places, boxes in the linked list where the name is equal to that input. That is where the string compare comes out being what? The string compare comes out being 0, right? We'll be doing a string compare. This is lowercase. STRCMP, string compare, INPT, with wherever we are in the list. So that would be current. So that's where we are on the list. Now I want the name part. So we want to keep on going until, so this input would have, that's what would have the Dan in it. If you're searching for Dan, we're looking for that. And if we find a Dan, then what comes out is what? A 0, right? If these two things match, what comes back out here would be a 0. And if they don't match, so what does that mean? You have to search for where it does match. You're going to be searching all the way through the string, looking for matches. So if you just want to go all the way through the string, sorry, not all the way through the string, but all the way through the linked list. Here's head. Head has in it the address of the first box, which has some name, and it's linked up to the second box, which is linked up. Okay, here are all these boxes that are linked up. How do you go all the way through the whole list? What is code for that, right? If I just want to go all the way, we come to the last thing in the list. There's some last name, Zorro. There, the last name. So if you just want to go through the whole list, so I want to look at this box and this box and this box. We're going to start. I don't want to change the list at this point. So we're going to start at. We're going to have box asterisk current, and that's going to be equal to head. and you say what? While current is not equal to 0, and then down here you want the very last line is certainly going to be current is equal to current arrow next. That takes you to the next box, right? And so long as, the very last time current will have a 0 in it. The next here, the next in this box is a 0, and so we'll end up quitting. So long as current is not 0, do something. What do we want to do? Well, if the name, so again, when you say search for Dan, the variable input will have Dan in it. And so if you've got Dan, what do you want to do? You want to count it, right? So you need to have what? A variable to do the counting. That starts off with what in it? A 0. So you need some variable here. An integer variable that's going to start off at 0. And if the name, as you go through this list, if the name is equal, if the name inside of input is equal to the name in the box, you want to count it. So what do I need? What do we need in here? We need an if. This takes us through the whole list. Yeah, or yeah. And so down here, we're going to do, whatever that variable is, variable plus plus. If what? If the input value is equal to the name value, so we've got current arrow next, we also have current arrow name. So if input and current arrow name, so I'm going to write it out like this. Input INPT equals current equal. You can't do it this way, right? This isn't good C. You have to use the string compare. So if these two things are equal, we want to count it. So this works fine if you have integers, but these aren't integers, these are arrays of characters. So you have to do that string compare. Okay. So this isn't too much here. How do you check for an empty list? So I'm trying to talk you through these things so that you can do these things. How do you check for an empty list? Here's this list. What's the difference between this list that isn't empty and the list that is empty? Head has what in it if the list is empty? 0. Head either has an address, a non-zero address. Head is an address of a box. That's non-zero. What's special about 0 is that it's an address of nothing. So when you have 0 in head, it means the list is empty. And as a matter of fact, if we, I don't know why, let's see, I ought to be able to make this thing up here. Okay. I don't see it on here, which is disturbing. Ooh, I can hear humming too. But right here, close to the top of main, let's find the top. Oh, look, here I've got my global variable, so it's being defined outside of main. Head, and what value do we put into head? We put a 0 in. Because to begin with, there are no boxes in the list. So how do you check for an empty list? You check to see if head has a 0 in it. So that's, you can certainly say there, this is not, we don't need string compare. You can just say, is head equal to 0? If it is, you want to print out that error message. Okay, so that's this guy. What about quit? But see, okay, keep in mind, there are a couple things we have to change. Right now, inside of this loop, what are we scanning for? We've got a space. So white, so what is that? That space right at the beginning means no matter how much white space we've got, we ignore it. And we're looking for either an insert, an I, a delete, which is a D or a P. So inside of there, we need to put in an S for search, and we've already got the P, and we need a Q for quit. Okay. And search is like insert and delete. Insert and delete both take what? Insert and delete both take a name. What name are we inserting? What name are we deleting? And search takes a name also. So notice, so you need to certainly make a change here to include both the possibility of an S and the possibility of a Q. And look at, what's this part about? This little if here.
Put the input in those that way.
Yeah, if it is an insert or a delete, we need to go ahead and we need to scan for the name that we're inserting, the name that we're deleting, or if it's, we also need to include an S, right? If it's an S, then we're also, so this should be if it's an I, if it's a D, or if the command is an S, then we need to do this. Yeah. Okay, so we're just looking at changes. And then down here, this is where we actually do the command. We have this big old switch. So this is still inside of the while, right? The while, open brace here, we print out what the command is. If the command is an I or a D or an S, we need to get extra input. Then we've set up these boxes, addresses of a bunch of boxes, current, prev, and NB new box. And now we have the cases. So if it's a P for print, we do this, and we break out. The print is finished. If it's an I for insert, we do this stuff here, and then we break out. If it's a D, we do this part. So what, you have two more cases, right? The case of a search and a case of a quit, right? What will you do if it's a quit? I think, well, even more than that, you could do a return. Now, main takes what? Main is, so a break just breaks us out of the enclosing structure. So here I've got this switch. When I get to this break here, I'm not going to fall through and do this stuff. Without the break, once I've done case P, without the break, I'd fall through and do this. So the break is breaking us out of the switch. So there's a closing brace somewhere way down there. And that's breaking us out of there. A return, though, is stopping the function. And what function are we in? We're in this function, the name of our function is main. So we're in main. So when main expects to get back what? Give back an integer. So you need to return. Doesn't make any difference what value. Normally, if things are successful, you return a 0. So quit, the code for quit is, so you don't need the break, because not only return, yeah, it breaks you out of everything. The function is finished. The main is finished and execution stopped. So that's quit. Okay, so this is a little bit of work because you have to do work in several parts. In this, to do the print, yeah, well, we have the, right down there at the bottom, let me see if I can't move that up a little higher. We've got the code for, here's the code for this right here. I can move it up yet a little higher. This is the code for print, case quotes, single quotes P. And right here we go through and print everything out. But if head is 0, notice we take the valued head and put it into current. And if while current is not 0, we carry this out. But if current is 0 even before we get started, we want to print out the thing about that the list is empty. Okay. So when should this be due?
So
What? Well, that's a possibility. We need to have a test in here.
When's Thanksgiving break?
Not next week. We have next week. Why can't it be this week? It's not this week, it's not next week, but it is the week after. Yes?
just to clarify, so we're adding two commands, what command and search command?
Yeah, you're writing the quick command, the search command, and we're changing the print command a little bit so that if the list is empty, we should print the words empty list. So those three things. Put in a search, so there's, you have to make some changes. So that's S followed by a name that we need to get into the input variable. Q doesn't take anything after it, we just want to quit. And P is the same as it was before, except if the list, if head is 0 to begin with, we want to print out something that says empty list. Otherwise, what do? We print out all the names in the list. So that's what we've got right now. It prints out all the names that are there. So if there are no names there, it does nothing. That loop, so if head has a 0 in it, we put a 0 into current, and then that loop says while current is not 0. So if current is already 0, that thing does nothing. Okay. So you are modifying the print command, you're adding in a search command, and you're adding in a quit command. Not much. And then we need to have a test next week. When next week? So today is Wednesday. I'm willing to say it's either going to be Wednesday, Thursday, or Friday of next week. I will pass out, I suppose, on Tuesday, kind of a list of topics and kind of things for you to study. But then, and then the test, it'll be a 15-minute test. And if perhaps what I'll do is I'll actually give you kind of a fake test so that you have, that the real test will be like that, but changed, not identical. That look okay or not okay? Or?
Is the test going to be over linked list, or is it going to be over a variety of different things?
Certainly linked list will be on there, but yeah, everything we've had since the last test. So I need to go back and think about what that is, and so I will get a sheet out on that so that you'll know.
So the homework will be due on Tuesday, and then
I'm willing, yeah, sure. The
and then
homework,
Friday the
right.
exam or that quiz.
Then the Friday would have, Thursday or Friday will have the test. Think about when you want to have it. Who isn't going to be here next Friday? Okay, we'll have the test Friday. It's normally if somebody says, "Well, I'm taking my Thanksgiving, a day early."
But the class is at 9 o'clock, so they got plenty of time to get on a plane.
It seems to me. We have graduate students that are from India, and they get cheaper rates or something, and So they sometimes like their finals, or, I don't know, it's a totally different problem. Yeah. Okay. Let's take a look. We still have some time, and there are other kind of interesting things to do to linked lists. Let's look at something else. Let me show you something else. And so I'm erasing this because you have what it is, right? And maybe he's even, I don't know, have you been recording this?
Should still be going.
So here's let's look at something like, I don't know, 3x squared plus 7x minus 5. What is that? What do they call that in math classes?
Trinomial.
It's a trinomial, or in general, it's a bunch of terms put together, a polynomial. Nomial means term, and poly means many, so you can have many terms. And what do mathematicians do with these things? Well, they add them, and they multiply them. We'll stick with these two. They add them and multiply them. Yeah. Think about this, that we could store this way as a coefficient, this 3, and exponent 2, and then a next. So I've got three things: a coefficient, COEF, an exponent, EXP, and next, which takes us to the next term. And the next term here happens to be a coefficient of 7. If I don't have an exponent, it's a 1. And then we have a next field that takes us on over here. This constant, that's like x to the 0. So I still have a coefficient 5. I have an exponent of 0. X to the 0 is 1. And I've got a next field here of 0 because there isn't another term. So polynomials are an awful lot. We can think of polynomials as being, we can store them as linked lists. And so we could then add polynomials, multiply. I mean, the rules are pretty simple here. Adding involves what? You look for like terms. So if I have another polynomial here, I don't know, 5x minus 2x squared plus 40. This and this are like terms. They're both x to the first, so I combine them. 5 plus 7 is 12. So we're going to have, so the result would be 12x, the first. I've got minus, let's see, this is x squared and this x squared, so these are like. This is a minus 2 and this is a 3, so a minus 2 and a plus 3 makes 1. So plus 1x squared. And then I've got a constant of minus 5 here and a constant of 40 here, so that'd be plus 35. So the point is that you could then, we can combine, to do the adding, we combine like terms. And then multiplying is what? You take every term here times every term down here and you combine like terms. You probably want to write these things the same way. Usually you write them like this, where the exponents go down. Here I've got exponent of 2, exponent of 1, exponent of 0. So this one isn't that way. To rewrite this one, we end up rewriting it minus 2x squared plus 5x plus 40. Now, then the exponents go to 1, 0. So that's a possible final project. I don't know that that's necessarily super appealing, but it's kind of nice, that you end up, one of the things that you can do with computers is you can get them to do algebra. And we're going a little ways here. We would be getting the computer, so people even call that artificial intelligence. Why, only humans can do this work, and well, this doesn't look too hard to get the computer to do. But there was a time where they thought, yeah, only humans can do this. But so that's what kind of makes it artificial intelligence. So that's not a bad final project. What do you think about that? Oh yes, I'm really excited. It does. So notice we don't have to store whatever the name of the variable is. If you want to get interested, yeah, then I need, this is x, and this could be like y squared, but we'll stick with just a single variable. So you don't even have to code the variable in, because we're assuming that it's say an x. So I'm proposing this as a final project. If you really, really, really hate it, I don't know, maybe I could find another one, but you might end up hating it even more. Yes?
Basically just an expansion of the expression program we wrote.
That's it. Oh, well, yeah, this is, yeah, we wrote the program that did adding and subtracting and so on. Yeah, I think this is a little easier. That one was where you had to worry about precedence. Here, what you'd have at any given moment is you'd have several polynomials. And so we're not going to have a single, we aren't going to have a single linked list. Say I'm going to have this polynomial and this polynomial. So I mean, that would be 2 linked lists. And then what we'd be doing when we added them, or when we multiplied them, would be we'd be making a new linked list that would be the sum or the product. So what do you do with linked lists? You want to be able to print them out. You probably want to put them in standard form, and standard form would be, exponent, largest exponent, the second largest exponent, and so on, kind of standard form. So then printing them out is pretty much a snap. You go to the, so if you want to print the first polynomial, we'd say something like P1. That would print the polynomial stored here at index 1. If you wanted to print the second polynomial, you'd say P2. You'd print the polynomial that's indexed here. So we'd have an array of pointers here. So rather than having a single linked list, you've got a bunch. And then we'd have a print operation. We'd have an add operation. So the add operation would look like add. We want to add polynomial 1 and 2 and put it somewhere. Maybe put it in slot 3. Multiply polynomials 1 and 2 and put it in slot 3. So we'll leave 1 and 2 alone, and you specify where to put it. So I'm going to put the result down here at index 3. So this is a proposal, and I'd help you with it. Yeah, no. And you have to deal with slobs. Well, I'm talking about users. You know, users will sometimes put in things like 2x plus 3 plus 7 plus 7x. They'll type in stuff like this. And what about this and this? These are like terms, right? They both are x to the, that's really pretty. They're both x to the first, so we ought to combine those and get 2x's and 7x's. That's 9x plus 3. How do I know they're like terms? Because the exponents match. So one job is to take the polynomial the user puts in and get it combined correctly. So I mean, what's the user going to be typing in? I don't want to look at this. There we go. So we have some decisions to make about what the user will type in. What we need are coefficient, exponent. So this would be two, you know, we can have them type in the x or not. You know, we can have them type in 2x1. So that means 2x raised to the first power plus 3x0. Or we could try to be a little friendlier, and if they type in plus a 3, then we know that's x to the 0. I don't know. But part of the job will be able to take that the user can do things like this. He or she can type in things with several like terms, and then we need to combine the like terms. And what should be first? The first term should have the largest exponent. Suppose they type this in. You can't trust users. I hate them. Say they type in 2x squared plus 5x minus 2x squared. Or maybe they type in this, minus x squared minus x squared. You can't trust these lousy users. So the first term, I've got this guy here, that's fine, but I have a minus x squared here and a minus, so altogether I'll have 0x squared. What do you normally do if you've got something with a coefficient of 0? You just remove it, right? It's 0. 0 times anything is 0. So you don't want to keep, yeah, so I combine a minus 1 and a minus 1 and a 2. That adds up to a 0. But I don't want to keep 0x squared and multiply it and add it to other things because it's just a 0. So this drops out, and so this becomes what? This becomes just 5x. So an important thing where a bunch of work is done is to do the simplification of combining all the like terms, and each time if you do have a 0, drop that term out. Return that box to, you know, we don't need that box anymore. Yeah. Okay, so so for us, simplify means to get one term for each, get one box for each term, and if the term has a coefficient of 0, we don't need that box at all. Okay, so that's it for today, I think. Well, I mean, I've got 6 minutes left. Do you have questions? Hey, we could talk about the election. Yes, you want to talk about the election or this?
No,
Yes.
I was just curious, like, if there's more than one variable, say like there's X, Y, and Z, and what you're talking about is that.
So that's a little more complicated. Then what's a like term? You have to look for terms where the exponent on the X, the Y, and the Z all match up. So if this is 2, 5, 7, I want to combine all the terms that have x squared, y to the 5th, and so if there are a bunch of terms, a coefficient here, if I have a bunch of terms, so these things are like, if the coefficients on the x, the coefficients on the y, and the coefficients, if they all match, then they're like, and so we add up the coefficients. Yes?
So how would we go about
But
making
we'll stick with just x and not do that, yeah.
So would we go about making like a data structure like a polynomial, and in the data structure it would have the constant, and then it would have the coefficient and its power? That's 3 different.
Yeah, so
lines.
coefficient, exponent, and then a next to take us to the next,
Yeah.
next term, yeah. And so a polynomial is just a bunch of terms linked up. And then you like to have a polynomial that is simplified, so if the user has put in several like terms, we want to combine all of those like terms into one by adding up the coefficients. And if the coefficients add up to 0, we want to drop that term, we want to drop that box completely out. We don't need that box.
Okay, so what would be, what would our command be like exactly? Would we like be entering and ask the user to enter in a polynomial,
Yeah,
then enter in a command and then
Yeah.
enter another polynomial?
yeah, so one command would be an enter command. I don't know, E for enter, or, and so what should appear after that? Maybe we want to say where they're putting the polynomial in, and then we want, so we specify where the polynomial. So we have this is the we indicate where the polynomial starts. What box? So this is like a number. Maybe we have up to 10 polynomials. I don't know, some number of polynomials. So we indicate a start, and then after that we're going to be putting in a coefficient and an exponent, another coefficient and an exponent, and we let them enter it any way they want. You and I have to make some type of agreement about, do we want them to put the x in also, so it's coefficient x. It's what is nice for the user. We don't really need that. What we need is a place for a coefficient, and an exponent should be what? It should be a, and that's an integer, right? A positive integer. Maybe 0 if we allow it. So we're going to have pairs like this, coefficient, exponent, and then when they hit the enter key, they're through entering their polynomial. And then we want to store that. So we want to store that. We want to create a bunch of boxes and store that information. So coefficient, exponent, next. Okay.
What about the operations between the combination?
Okay, so there's this enter operation.
Yeah.
And then-
Okay, I got it now.
And then in addition, we have an add operation, add polynomials 1 and 2, and put it somewhere, maybe put it in slot 3. Okay, so so this would be, it would actually do work that normally gets done in what do you multiply polynomials here? 115 or high school or middle school? Someplace you do polynomials. But we'd be getting the computer to add and multiply the polynomials. I mean, we could do division too, but I mean, I'm willing to stop with addition and multiplication. So this is a standard problem. You should be able, if you look for this on the internet, you will find stuff. Again, but though I want, whatever we work in class, then I want you to use that. If you do something wildly different, well, where did he get that? And I might ask you a question about it or something. I don't, so if you aren't gonna, if you want to change what we've done, I want you to ask me about it. I don't want you to just, giving me a working program isn't gonna cut it. I want you to either do it, I don't insist that you do it my way, but I do insist that you tell me and ask me if you're gonna do it your way. And I'm gonna either say, yeah, that looks good, or try to convince you not to do that. Yes?
Would this be like a make or break for this class?
No, it's a final project. It's more important than, maybe the things we were doing way, way back at the beginning. But it's, I don't think it's more important than the precedence and being able to do the expressions.
No, like say if you didn't do well on this project, would you still be able to pass the class? I mean, we have.
Yeah, I
we have bad ones,
suppose.
right?
I mean,
That's
it's-
the only concern I have.
it's not a guaranteed pass. We've got, what, how much time do we have? 3, 4. Yeah, we have a little bit of time. So after the break, there's like,
2 weeks.
yeah,
One of those weeks is study week, isn't
So it's only,
yeah, but you can do things then. You can't, let's see, tests can't count more than what, so many %, and maybe let's look at the rules. I don't want to violate the rules, okay?
Or
Hmm?
rules for what? Study week or?
Rules for study week, yeah.
I thought like the biggest rule was students sign homework. No, seriously, like during that week, we're not supposed to have homework.
Well, let's look at, if that rule exists, you're gonna have to work hellishly fast. No, okay, I'm teasing, we'll just, yes,
Do you have time after this class?
sure.
Okay.
Let's look up what the rule is. So no, it's not, this is not a make or break thing.